Today we're going to take a look at section 10.4, measures of central tendency and variation. We'll cover about half of it today, and then we'll finish up the other half on Monday. We're going to start with the central tendency portions of this. And the first one is one that you're very familiar with. You may or may not be thinking of it always with this word, but it's called the mean. The mean, also called the arithmetic mean, is the average of the values found by adding the values together and dividing by the total number of values. Anytime you talk about your grade in my class, this is what you're talking about. You're adding all of your points together and you're dividing by the total number of points, and then you multiply by 100 because you want it as a percentage, right? It's that kind of an average. Now, there are three types of measures of central tendency. They're all averages, but they're found in different ways. So you can't just say the mean is the average, because the average actually applies to all three of these descriptions I'm about to talk to you about, okay? So if you want to say arithmetic mean, or you're talking about adding all the values together and dividing by the total of values, that's what we talk about when we talk about a mean. The median is the middle value. It's found by listing all of the numbers in numerical order. If we have an odd number of numbers, it's simply the middle value that is our middle. If there's an even number, what happens is we have two values that are in the middle, and then we add them together and divide by 2. We average them, like an arithmetic average between the two. So kind of a visual picture of a median would be if you had, or if I even had, all of you stand up, height-wise, shortest to tallest. Because there's 11 of you today, it's an odd number of people, we would have 5 people in from this direction, 5 people in from this direction, and there would be one person in the middle who would be the median height. And we could say 50% of the class is taller than this person and 50% of the class is shorter than this person. That's what the median does for us. Okay. If you think about doing a median grade, sometimes people want to average their grades together like we do normally, and they want to say, like I had a test that I finished grading, not your test the other day. The average arithmetic mean was 70.4. So what I'd kind of like to say is that half of the class passed and half of the class didn't, right? Roughly speaking. And roughly speaking, that's probably true, but it doesn't have to be, because that's not how means work. Means don't always find the middle value. Sometimes, depending on how things are bunching up, like if I have a whole bunch of high grades and a whole bunch of low grades, that number might not be the 50th percent mark at all. Okay? So this is an ordering process and taking a middle value. The last one is the mode. The mode is the number or numbers that occur most frequently. So I have a daughter who works at Taco Mayo, and if we wanted to know what the average employee pay is at Taco Mayo, the mode might be the way to go, right? Because if you took all the people who are, making minimum or nearly minimum wage, and you added their salaries each individually in with the person who's there 60 hours a week because they're managing the place, and then you divided it by the number of people, somehow that 60-hour-a-week guy or girl is going to be pulling the average up. It's going to sound like everybody makes a lot more than they really do because it's going to unweight things, right? It's going to make things off kilter. But most of the people who are working there, they don't make anywhere near the amount that the 60-hour-a-week person does. Does that make sense? So sometimes a mode makes the most sense in the context of what we're working with. Mode is what happens a lot of times when a child looks at their grades. Like my kids have Power School. It's a grade reporting program so I can see how they're doing. I use it to figure out whether or not they're turning their work in. That's what I use it for as a parent. But I can go out there and I can look and I can say, look, they've got all of these A's. Oh my goodness. And then how in the world do they have a B in the class? Well, because there's this one big giant project or this big giant test that was worth a lot more than those little bitty daily assignments, and it matters more, right? So yeah, that's why they've got a B, is because it's not the mode I'm looking at, it's the arithmetic mean that I'm looking at. All those other assignments weren't worth nearly as much. And so people use mode sometimes when it's also not really appropriate to use mode. I remember having an instance when I was here a number of years ago, and a student sitting in my office and goes, I've always done really fine in my math classes. I mean, I never passed any tests, but I always had a B in the class. I always had a B in the class. And I'm sitting here going, what? Because they got homework grades that were high, right? Because they could work with other people, and they felt like that actually should have weighted itself more. And so those lower test grades, which were not weighted very high in high school, weren't bringing them down the way that they are in college. Because once you're in college, those test scores are the killer, right? I mean, they're huge compared to your daily work. And so she was looking at and thinking about mode in an appropriate way. Okay, so we're going to actually take a data set, and we're going to find all three quantities: the mean, the median, and the mode. We'll just do them in order that they're presented. So we'll start with mean. So what would I do to find the mean of these values? Yeah, I'm going to add them together. So 18 plus 22 plus 22 plus 17 plus 30 plus 18 plus 12. And then what I'm going to do after I add them together? Divide by 7. Why 7, Matthew? There's 7 different values. All right, and so we're going to work on, try to remember what your book does. Based on what my notes say, I think we're going to go with 1 decimal. So what happens when we add these together and divide by 7? 19.9. Is 19.9 okay? 1 decimal?
Okay.
Is that good?
Sorry.
It's okay. All right, so we have an average of 19.9. Now, because this doesn't have any context for us, it doesn't have any meaning either, but that's the numerical value for our example for the moment. How about the median? What would I do to find the median?
Order least to greatest.
Yeah, I need to put them in some kind of order. Least to greatest is fine. Greatest to least is fine. Either way. So least to greatest is what I heard. So I'm going to do 12, 17, 18, 18, 22, 22, and 30. And this one has 7 values. It's an odd number of values. So if you think sort of like working your way inward, ticking them off, there is exactly 1 value in the middle. And it happens to be this, circled the wrong one, this one right here, the 18. And so my mode is 18. I'm sorry, my median, I'm still not using the right word. The median is 18. Now, mode is the number that occurs most frequently, and it can have more than 1 mode. So if you have 2 modes, you would call it bimodal. If you had 3 modes, it would be trimodal or multimodal, right? But you can have more than 1. And in this particular data set I do, what are my modes in this set? 18 and 22, and I simply have 2 of them.
Are we ever going to need to know those words you just said, like the 2 and the 3 one?
No.
Okay.
No. Just know that you can have more than 1 mode. Yeah, it's certainly possible to have 2 answers on this one. You can't have 2 answers for a median, and you can't have 2 answers for a mean. Let me show you what would happen if you had an even number of numbers. That sounds funny, but an even number of numbers on your median. So let's use the same data set that I have. And I'm just going to put another one on the end. So let's say you had 8 numbers. There's actually 2 numbers in the middle, right? Both of these would be considered the middle values. And so I don't have 2 medians, even though they're both in the middle. I would actually average those. So what's halfway in between 18 and 22? 20. And if it wasn't a number that you were obvious when you're just looking at it, like this one's pretty clear, you just add them together and divide by 2. So this median would actually be 20. All right, so, but modes can have more than 1. All right, a little bit of an application to think about this in another direction. This tells us that the mean score on a set of 20 tests is 75. And it wants us to sort of backtrack and figure out what the sum of the 20 test scores are. So normally when I'm calculating this, right, what I literally do with my tests, did this yesterday, is I took all the test grades, I add them together, and divide by the total number, just like I did on the the mean on the previous problem. Add them together, divide by the number of tests. Well, this is going in reverse. I know the average, and I know how many tests I have, 20, and I want to find the sum. So the mean, when we described it before, is the sum of all of the scores divided by the number of scores. Okay, does that make sense? I mean, I didn't exactly write it down like that before. I just sort of described it in words, but that's the same thing, right? There's three quantities here, right? I have the left-hand side that says mean. I have the numerator that says sum of scores. I have the denominator that says number of scores. And I know two of them. So which two do I know?
You know the mean and the scores.
Right, I know the mean, which is 75, and I know my number of scores, which is 20. And if I know two things in an equation, I can always find the third, right? So I'm going to find this one. If you want to put a variable there, you can. If you just want to write the words out again and just a sum of scores, that's fine too. We're not working with a lot of algebra here, just a tiny bit. What would I do to solve for the sum of the scores, though? Yeah, I would multiply by 20, right? So what do I get when I take 20 times 75? I get 1,500. The sum of the scores is 1,500. Okay, we're going to take that idea and take it one step further. We're going to talk about a football team. We're told the mean weight of the 7 linesmen, those are the big guys, right? I'm looking at Matthew. Matthew, true? Okay. I have about this much knowledge of football. Yeah. I enjoy watching, sort of. Games are so long. It's a lot of time to watch.
They're so good.
Sometimes. All right, so the mean weight of the 7 linesmen is 230 pounds. So that's kind of like this information over here. I know the mean of how many people, okay? The mean of the weight of the 4 backfield members is 190 pounds. Okay, so these are the lighter weight guys. If we want to know the mean of the 11-person team, what would we do? Well, we know, again, from our previous work, that the mean is the sum over the total number, right? I mean, that's the kind of condensed way of writing it. That's what we're looking for. Well, I don't know the sum, but I know the means of each of the individual groups. But the individual groups are not the same number of people, right? One group has 7 in it, and one group has 4 in it. So I can't just add the 230, 190 together and divide by 2, because it's not the same number of people I'm talking about. So any idea about how I could use the information I've been given to find the sum, or not the sum, but the average of all of these guys?
Multiply the 230 by 7 and then 190 by 4, add it together, and then divide it by 11.
Okay, 230 times 7 is essentially what happened when I multiplied my 75 over here by 20, right? That would actually give me the total weight of the linesman. And then 190 times 4 would be doing the same thing for the backfield. So this amount right here actually is the numerator of what I'm trying to find. What's my denominator again, Hannah? 11, because I have 11 guys. So if I take 230 times 7 and 190 times 4, what do I get?
2,370.
Is that before or after your... That's way too many for dividing by... Is that before you divide by 11?
Sorry.
That's before, yeah.
And then divide by 11? Okay, fair enough. 2,370 divided by 11, so then what do I have?
215.5.
215.5, and I'm going to have units because there's context with this problem. What would it be? Pounds. Very good. Now, just a sort of quick check step, whatever I get had better be between 190 and 230, right? And my number is. So the answer is reasonable. So when you get to the answer point, you should look back and make sure that it makes sense. And this is a reasonable number given the values that I have been given. And it's also reasonable that it is more highly related. It's closer. It's closer to the 230 than it is to the 190, right? Because there were more in the 230 category. There were 7 guys over there, right? and there were only 4 guys in the 190 category. So it also seems like it should be leaning toward the 230, and that also seems reasonable. Okay, everybody good with that? Where have you seen this used in real life? I suspect most of you have done something at the beginning or at the end of a semester before where it says, what do I need to make in order to get a blank, blank, blank in the class, whatever your is. It's a C or it's an A or it's a whatever, right? This is what I do in my office when students come and ask me this question, is that I back into it in very much the same way. I figure out what we've got so far. How much points do we still have left? What are we trying to achieve overall? And we can find a grade that makes sense. So much the same kind of a computation. Okay, this is all measures of central tendency. So we're shifting now into measures of variation. And we will do just a few of them. I think we'll finish this page before we quit today, and then we'll save the rest for next time. So range is the first one. Range is simply the difference between the greatest and the least value in the data set. Like you actually just subtract biggest value minus smallest value. If you're splitting up your data into quartiles, quarters, like 4 quarters in a dollar, 4 quarters in a football game, like that, the lower or the first quartile is the first 25% of the data. The middle quartile is the 50% in the middle, so from the lower 25 to the upper 75, right, like that middle part. And then the upper or the third quartile is the higher end. It's the final value. It's the fourth quarter is what it really is. The third quartile is the 75% mark. Okay, so in terms of like a picture of a number line of what's going on, if you had this number here at the beginning is your lower value. Sometimes they call it a lower extreme. This one is your upper value or upper extreme. In the middle, dead center, what's the middle value called? You guys know it from a previous slide. The median. It's the median. And then if you split the difference between the median to the lower value, that is the first quartile, it's Q1. And splitting the difference between the median and the upper value is your third quartile, Q3. Okay? That's visually what it looks like. And we're going to use those pieces of information in a second here. I've got to finish defining mine, and then we'll actually take that picture into another screen. The inner quartile range is the difference between the lower quartile and the upper quartile. So visually, this distance right here is the inner quartile range, IQR. So again, it's a subtraction, higher value minus lower value. Just like if I go all the way, higher value minus lower value, that's my range. Okay. I mentioned this already, but the lower extreme is the smallest value. The upper extreme is the largest value. And then this sort of number line picture that I've created with the lower and the upper and these pieces all marked, we're going to use that number line picture to create something called a box plot. A box plot is created from the lower quartile, median, upper quartile, inner quartile range, and lower and upper extremes. And it lies above this sort of a number line description that I've sort of drawn out without any numbers on it right now. So we will create a box plot with some data to show you how it all plays together. And that's where we'll stop for today. So, am I good to switch my slide? All right. You've seen this data set before, right? A moment ago, we put it in order from least to greatest. So I'm going to do that again on this screen. We have 12, 17, 18, 18, 22, 22, and 30. I think that's right. And we identified the second 18 as my median. Yes? Everybody good so far? All right, so we're looking at all of the values that lie below the median, and I want the middle number there, which is a 17. So the 17 right here is Q1. And I'm going to do the same thing for all the values that lie above. The middle value here is it's the second 22, right? It's 22. And this is Q3. And then on the ends, the 30 and the 12, these are my lower and upper extremes. This is my upper, and this is my lower. Okay, good so far? All right, we're going to create a number line, but our number line has to be true to form. Like, I can't make it look evenly distributed like this if it's not really evenly distributed. I actually have to have the number line, with the scale appropriate, just like anytime we've done other scales of number lines and so forth. So when I draw this number line, I need to have 12 at the bottom and I need to have 30 at the top, but they need to be evenly spaced out otherwise. So 12, 13, 14, 15, 16, I'll mark 15, 17, 18, 19, 20. I'm going to mark every 3, I guess. 21, 22, 23, 24, 25, 24, 26, 27, 28, 29, 30. Okay. So I've gone from 12 to 30. It really should end at 30, so I'm going to erase my extra that I have. And I'm going to just shift this down because I didn't give myself enough space. This scale is actually lower than my graph. My graph is going to be above this, but using this scale as a reference. That's what it's going to be. So what we're going to do is we're going to plot a point at 12, because that's my lower extreme, at 17, because that's my Q1, at 18, because it's my median, at 22, because it's Q3, and at 30, because it's the upper extreme. So I've got 5 dots plotted correctly. Yeah? All right, so here's what we do. The first 2 dots get connected by a line segment, as do the last 2 dots. Those are the whiskers of my box plot. In the middle, I'm going to draw vertical bars through my other dots. And I'm going to make a box connecting them. So there's a line at Q1 going vertically. There's a line at the median, which is also Q2. And then there's a line at the Q3 mark. We need a title for this, but before I get to that, because this is a not very exciting title, because I don't have any context, right? But what this does is, at a glance, you can tell me what the lower value is, what the upper value is. You can tell me where 50% mark is. You can tell me where 25% of the data lies. This picture is really, really informative with very little marked on it. You know a lot of information from this picture. You know that the majority of the data values are really kind of on the lower end because the box and whisker, the whisker over here is really long. There's not a lot of data over there, right? It took that longer piece to get the top 25% of the data. Whereas like between 15 or between 17 and 18, it's really bunched up and really tight. That's telling you that there's a really concentrated amount of data right there. Now, I realize we only have 7 data values, but the majority of the time that box and whisker plots, as well as most data are used, you have a lot more values. So you really get a feel that this is actually showing you where things are really bunching up and so forth. So just for the sake of saying we've got it, we're going to just write our title as scores on ... because I don't have any data to describe this. This could be ACT scores. These numbers actually are very close to what an ACT kind of score would be. But these are scores on something. This is my title. Whatever it is, it still needs a title, just like when we were doing the last 2 sections of material. Every time I draw a graph, I do a title. Okay? Any questions about box and whiskers? Okay. Oh, one more thing real quick. There is one more thing I meant to mention. When you're doing a set that's got an even data distribution, let me write the ones I'd written out before. I had, 12, 17, 18, 18, 22, 22, 30, and 31. I mentioned this one before, right? And we said, oh, look, I'd have to find the number in between here, and that would be the number 20 as my median. If I do that, I still have 4 values below the median, and I have to do the same thing again. I need the halfway point between these two to give me Q1, so I'd have 17.5. and I need the halfway point in between 22 and 30. Is that 26? Yeah, it's 26. And that would be my Q3. Okay, so if you do have an even number, you actually still end up with all 4 of the values on either side of the median that you have to find the middle point of as well. So that's something that occasionally comes up that doesn't show through with this particular example. All right, so we will stop for today. We will finish up next time with the other ways of doing measures of variation.